10. We've solved relatively easy day 9, and let's take a look at day uh, day 10. It seems parsing some kind of brackets challenge that's usually pretty standard. Let's simply recap for a few seconds how we solve our problems. We're using Go as a programming language that we get the solutions in. We're using ChatGPT, Bing, as well the OpenAI tokenizer to see how many characters the thing that we want to ask Bing, or eventually to estimate for if we make a request to the OpenAI API using their UI, and even once we did that, or twice we did that using some live book in Elixir. And yeah, that's shortly said. Usually what we do is read roughly the task without spending too much time, simply to get a rough idea what is the main purpose. After that, crafting our prompt that it's very standard, and starting with ChatGPT because of the limit that Bing has on size of the input, to not exceed 2000 characters, which in the case of the ChatGPT is like a number of tokens, and it's much higher. It's up to 4000, and as we can see, some words are simply one token. World, for example, it's one token and it's 5 characters, and that's make it much more compact. And let's go with day 10. Enough background. We are simply to remind, if you're joining the video for the first time, we've been in a submarine. We escaped some deep sea creature, and we've been hiding in a cave, and now we're trying to navigate in the cave, or avoid some obstacles there, and so on. And that are the current tasks, the last few tasks. You ask the submarine to determine the best route out of the deep sea cave, but it's only replies syntax error in navigation system on line all of them. Okay, now we're trying to use this navigation system to escape the cave, but we are getting some system error, and we need to correct the thing. Okay, and what we need to do, the damage is worse than you thought. You bring a copy of the navigation system, your puzzle input. And the navigation system syntax is made of several lines containing chunks. Okay, that's our chunks in instruction. Subsystem, we have we get this input, and we need to we need to count the brackets. We need to parse the expression probably to see if it's valid, and so on. Let's read that part. The navigation subsystem is made of several lines containing chunks. There are one or more chunks on each line. Okay, one chunk um, it's not per line. We can have them concatenated. And chunk contains zero or more other chunks. That means that this bracket might be uh, nested in each other, like the examples here. Adjacent chunks are not separated by any delimiter. We simply need to find, okay, this bracket's open, and tuck of the other ones are inside, and okay, in this moment it's closing. That means that this chunk or subchunk is complete. And every chunks must open and close with one of four legal pairs of matching characters. Okay, and we can have this type of brackets, and they are determining chunks. As is more complex but valid chunks include and even very deeply nested, some that have different depth. Some lines are incomplete but others are corrupted. Find and discard the corrupted line first. Okay, we have some that are like open and they never finish, and we will need to consider this like incomplete. We have some other that are simply looking like a complete, but they're incorrect. Corrupted. Corrupted line is one where a chunk closes with the wrong character. That is when the character it opens and closes with do not form one the four legal pairs listed above. And here it's you start like that and you close like that, etc. Okay. And we need to identify these corrupted chunks. And here the most important part is that we have some lines that doesn't have such a corrupted indicator, simply the number of opening brackets exceed the number of closing brackets, and we'll need to ignore them. Okay, now stop at the first incorrect closing character on each corrupted line. Here in some nested one, whenever we see something like that, we should immediately stop. Did you know the syntax check actually have contests to see who can get the highest score for syntax errors in a file? It's true. To calculate the syntax error score for a line, take the first illegal character on the line and look it up in the following table. Okay, that's telling now the closing is this, but should be another one, etc. And for each of them I'm getting points. In the above example, an illegal was found twice. Okay, an illegal was found once. Okay, and I need to sum up of these illegal points. I need to see, okay, on each line to find the first illegal character, and after that score the points. I think it's the first part is clear to me, and now we can attempt with simply solving the problem. I will simply copy one of the solutions that we have from day 9. I'm pasting it here. Have rename. And in this case, let me delete the input because we'll have completely different input. Let me delete this part as well. Here in our prompt engineering, I will keep this part, and we'll discuss in a little bit what our initial prompt usually is and why. We don't have this solution, and okay, that is. What we usually do is simply to give some context to our prompting agent. We're saying you're a prominent competitive programmer. You have been invited to participate in a programming competition. You're given a problem to solve. That's so to say, we're telling ChatGPT, okay, we're talking for a programming, please took this role. And ChatGPT replies very standard. We that sure you would love to participate in programming competition and solve problem given to me. Please provide me with the details in the problem, blah blah blah. And now that's perfectly fine. It's exactly what we want to have. 1 second. Did I copy it correctly? And here in our second prompt, what we do is we are saying instruction, write a Go program that solves the problem, and read the input from our test file, because initially we do the debugging using this kind of input instead of having our complete input, which it's much harder to debug. Let me put the original input. Let me go back and grab our test input, which is much smaller and allows us for smoothly debugging. And also here we have some guidance what to expect as a output. We can see Visual Studio, it's here marking the files itself, and here is the task. Why we get this autocomplete? Because we already did that multiple times in using Copilot. In Copilot, remember all this stuff. Now let's get there. I would expect the solution to contain a stack with which we're going line by line and putting in brackets, and after that, when we see closing brackets, we're popping from the stack and comparing, okay, is this closing bracket matching the one that we lastly put, and if not, that means it's incorrect and simply need to check the points for the given bracket. It's quite standard problem, but let's see how ChatGPT does with solving that. One side note is that usually we were trying to iterate to the initially. In previous days we had input to ChatGPT, and we were so to say iterating on the solution. When the solution wasn't correct, we were trying to guide ChatGPT to fix this solution. That seems to be not working at all. Much better approach is when we are not satisfied with the solution, simply to press regenerate and like having bunch of iteration of the solution and see, okay, that seems very promising, it's exactly what I expect, and simply then continue with the debugging and so on and fixing eventual errors. In a lot of problems the error were connected with the output, not the output but the input formatting and so on, and they were relatively easy to resolve. Let me put it here, perfect, and let me add also the description, and let's look actually at the code. Does it look promising? Again, this Go program is made to be running locally, and when I'm saying locally, I mean to run it with simply running Visual Studio. If you try to compile the file and so on, you need to remove this path. Okay, that's look very promising. Firstly, we're reading the lines, all that looks fine. We're making stack, exactly what I expect. We have our runes, absolutely fantastic. We have our opening brackets. When we have our opening brackets, we are putting to the stack. How we are popping, that's the way in Go. You simply say, okay, I want to get everything excluding this one, and because the length it is array, that is 0 index and the last element will be 1 minus 1, we want to pop this to have the stack without this element when it's closing bracket, and we simply remove it. Here there's no popping, we simply read the last element always, and we're even having a check that we actually have an element, because it might be the case that okay, we're in a closing bracket but there wasn't even opening at all. Yeah, that stuff looks quite legit. The counting look legit, and let's double check what's the expected result. 26,397. It looks so correct. Let's have our input file and see how it's going, and if it doesn't work, we'll discuss what I think might be a problem. That's not the case. I was thinking that we can have starting with a closing bracket, and here we might miscounting that, but anyway, it looks very nice, and here we can see our way of breaking the loop, because we have a scan, and after that for the given line we just jump here to print the line, and we continue with the outer loop going through the line. I mean, it's using Go too, but it's yeah, in our case it's fine. uh, yeah, that was for today. Hope you enjoyed that, and see you in day 10 part 2. Have a nice day.